welcome to the next presentation. Some of you might have recognized there is a S when you have this HTTP at the end. You might use the thing that is underneath that S, and happy to have here the David from the OpenSSL maintainer team here on stage. Stage is yours. Thanks.
Thanks a lot for the very nice introduction. Hi, my name is David. Like the presenters just before, I'm part of Siemens Technology in Munich. But unlike them, I'm in the security department, and they're in particular in the PKI team. And today, as mentioned, I'm going to share how I became an OpenSSL committer and what this means to me. When preparing this presentation, I thought, this is my first time in an open source meeting like this. So when did I first encounter anything like open source? Maybe you remember? For me, it was in 1985. At that time, I had bought a very little pocket computer, which had 4 kilobytes of RAM. So on this machine, I knew each memory location in person. And the nice thing about this small memory is you cannot have big programs. And in our local supermarket, I found a magazine like this for users of such machines. And they had listings of basic programs in them. So source code printed on those magazine pages, so you could type them in and get something running. So this was open source back 40 years ago. Shortly thereafter, I graduated this a little bigger machine, a PC 1600, which had a wonderful Z80 processor. And I started programming not only in BASIC but also in the machine code, and got pretty deep into that, and bootstrapped my own development environment consisting of a disassembler, of an assembler, a debugger, everything written in machine code itself. And I was even asked to write a word processor at that time, and also this was directly in machine code. So when I shipped my software, it was not open source, it was not closed source, it was no source. With the money I earned this way, I was able to buy a Commodore Amiga, and then I finally went up to go to programming in C. Of course, a good prerequisite, what I'm now doing with OpenSSL, for instance. A little bit of history of OpenSSL. As we just heard, there's this HTTPS thing, and this came up in the 90s, so a few years later. And there were two people who noticed, okay, we also need security and need a library for that. And this was Eric A. Young and Tim Hudson. And they brought up a library they called like the names of the first letters of Eric A. Young, SSL EAY. A little later, they left for another job, and OpenSSL was forked, so this ESLI was forked, and they thought that the people doing it, how shall we name it? We could name it OpenTLS, because at that time TLS was already evolving, but it was not yet the IRC was not yet finished, so decided to stick with the original well-known name OpenSSL, and that's why we still are stuck with that 20 years later. And yeah, then this evolved, of course, over time, and basically there was one person who was doing all the maintenance, Stephen Hansen, and this also causing trouble. Many of you will recall Heartbleed in 2014. And at that point, it was really basically Stephen Hansen who was heavily overloaded maintaining this library. And there was another guy who had already been involved before, another Steve Marquez, and Steve helped to get much more funding and reasonable funding to start up a good team to maintain OpenSSL. And maybe you have seen this wonderful article, "The Internet is being protected by two guys named Steve. Since then, OpenSSL is in much better shape in terms of personnel maintenance and also in terms of tooling and processes. I will share a little bit about this. Maybe some little technical background. So OpenSSL depends on very few tools. This is also for portability, because even today it is supposed to build on machines that do not have things like CMake. Some old architectures, for instance. So we basically have just the C compiler stuff and quite a bit heavy use of Perl. Perl is, so to speak, the Swiss Army knife of OpenSSL. It's used for all kinds of purposes, for generating the big make file, for generating some code, for test scripting and the like. And by the way, Roger also has good experience with using Perl and coming into open source stuff quite some time back. Yeah, you see from the size of the code, lines of code of this, actually it's two libraries. The main library is called Crypto, still called Crypto, although much more other thing came into that. And nowadays the Crypto stuff is being moved into providers. And besides Crypto, there's the actual SSL or library, or it should be called TLS for the same reason as we've seen before. It's only TLS and DTLS at this time, and now it's even includes Quick. But there are many other parts in Crypto behind the scenes, for example, OSSP handling, HTTP, and the like. The version 3.0 was a major change in many respects. Since then, this uses semantic versioning, and this, for instance, means if we have any change in the API, this has to wait until the next major release. It will be in a couple of years only. But of course, we can add things, and in minor versions, no problem with that. And minor versions these days come out every half a year pretty regularly. Also, the license has changed in a way that is now a little more compatible with, for example, with GPL. When you are doing anything with OpenSSL and contributing to it, you will notice this code is quite complex. Of course, Crypto is not easy anyway. And there's a lot of low-level and partly pretty old code. So it's not that easy to maintain. There are many legacy features involved that are still kept for backward compatibility reasons. So anyway, this API and ABI compatibility is really quite a burden to get new things in, and sometimes even to fix things, not that easy. There's quite some technical depth and also in other respects. For example, in the structuring, you've seen there's a big library, monolithic one, still called Crypto, which does all kinds of things in the meantime. And there's also some code redundancy that could and should have been fixed, I think. And of course, the shortcomings of C with the manual memory management trouble, the ambiguity between integers and booleans and the like. So OpenSSL is still very widely used, also in Siemens. Who of you has not been using OpenSSL so far? I see no hand. Well, of course, there are many reasons for this. It's free, open source. It's easily available with Linux distributions, at least. It's very well known, so many projects had already been using it, so it's kind of obvious to continue using it. And it's very feature-rich. All kinds of crypto code that you could dream of is included. And since the 3.0, it has a really very flexible, future-proof API for cryptography. So whatever comes up in the future, fancy quantum computing stuff, everything can be integrated via this API, and it's called crypto providers. In particular, also hardware and support for hardware crypto storage and the like. This is all relatively good to integrate into OpenSSL. There are also downsides of OpenSSL. It's pretty bulky, at least for very small systems, not really usable. It's complex API, it's hard to use. And memory safety and things like this are always a pain. So for these reasons, actually, some competitors have come up with small footprints, for example, embed TLS, and some with more lean and potentially more safe design, like LibreSSL, Boring SSL, and the like. And of course, there's also other languages, Bouncy Castle for Java developers, for instance, or C#. And just yesterday heard about Rust TLS. Come up last year, I think. So we can think of OpenSSL being this big dinosaur here. It's heavyweight, but it's very strong. It has all kinds of weapons. And for sure, it can also lay eggs and give milk. How did we come, or my team come to contribute to OpenSSL? OpenSSL already has been using or providing support for using certificates. You will know X509 certificates are essential for proving the authenticity of some entity, maybe a device. There are many Siemens devices need to talk to each other securely. That's why they need certificates. And OpenSSL, okay, it supports that, but what it has not been supporting is the management of such certificates. So how to request a certificate from a PKI in a secure way, and how to revoke it if needed. There are various crypto protocols, certificate management protocols around since more than 20 years. For example, CMP, CMC, and SCAP. And later, some others joined, particular EST and Let's Encrypt, but nothing of this was in OpenSSL. There was an attempt by Martin Pelo, who is also a former Siemens colleague who was moved to Nokia at the time. He was dealing with LTE, and LTE in the standardization specification required using CMP, and that's why he started implementing it based on OpenSSL, and he came up with a patch called CMP for OpenSSL. And he also tried to bring it upstream to OpenSSL. In the end, it didn't succeed, and one of the obstacles was that he was using a third-party library, namely curl. And this is, of course, not something that OpenSSL didn't want to have another library as a dependency. They don't depend on anything. But somehow, on the other hand, the HTTP support of OpenSSL at that point was very, very poor. I think this was the point where everything got stuck. Around the same time when this happened, we had been using in our team EST, or starting to use EST as a management protocol, and found the libEST of Cisco, which is their reference implementation, and I started using and extending it for myself, and then we thought, oh, let's give this to Cisco. But they were not really interested in that for various reasons. Okay, one reason certainly was it was simply too much of a change at a time. So I had made some mistakes in contributing to such an open source project. But we learned from this lesson when later doing this CMP stuff with OpenSSL. And we also figured EST is not the ideal management protocol, because it's not that flexible and doesn't provide end-to-end security, which can be very important for the authenticity of certification requests. And that's why we went over to using CMP. So the whole Siemens product PKI is now using CMP. And for this, we also need CMP clients. Our devices in Siemens need these clients for requesting certificates. And I was asked to take over such a development. And then we figured, okay, there's Martin Pelow's code, and I tried improving it. Yeah. And as we already heard yesterday from Adrian, I think it was, certainly it's not a good idea to have a patch all the time. So that's the problem of maintaining this. And it's not suitable for build chains. So we had to come up with another solution for our customers. And an obvious approach could have been to just start another standalone library, which could depend on OpenSSL and add the required features. But at least at that point, it was not so easy with the given API to make it really standalone. And would be a more problem into the future, the long-term maintenance of this independent library. Who should do that if maybe our project have ceased? So someone should take over the long-term maintenance. So then the idea came up: we should push this really upstream to OpenSSL, and in the long run get away from at least part of the maintenance burden. And in the meantime, we also provided an intermediate library for our early adopters of CMP in the company, who were able to use CMP right away based on whatever OpenSSL version they already had. And this approach of upstreaming CMP into OpenSSL was funded by various parties in Siemens jointly, and this took several years to go. So we had learned our lessons. We first went to OpenSSL and asked them, would it be interesting for you to have CMP included? And after a while, they said, yes, let's do that. And let's do this before the next major release, which was the OpenSSL 3.0. That was about to come a year after that. So suddenly I had quite a big pressure getting more than 20,000 lines of code into a security open source project. Another lesson I had learned, okay, we need to slice this into pieces, and so there were 12 chunks, 12 pull requests, so each of them having more than 1,000 lines of code or test code or whatever it was to include. And I had to add quite a number of tests, and I had documentation, everything needed from the OpenSSL perspective. So the original code size went up and up, and everything around this. So quite a hassle and of work. And when there were some review feedbacks, I had to handle them and then wait for another review feedback and so on. So it took a while and was pretty stressful to get this all in time for the 3.0. During this process in January of 2020, suddenly I was approached by OpenSSL, hey, would you like to join as a committer? This was a very nice offer. So I quickly accepted that. And this was really very helpful for this upstream process. Mostly because I had more insight into the project itself, but also for organizational reasons. Each pull request needs 2 approvals from OpenSSL people. And at that time, being a committer, I could be my own approver. So rather than having to wait for 2 reviews to finish and I only needed 1, and this really speeded up the process quite a bit. And I think only because of this, we were able to get this contribution into the C0 before code freeze. And in summer 2020, finally everything was in there, so in time for the C0 release. Yeah, it was really, I was so glad, very glad that this worked out. Yeah, a little background on the structure of OpenSSL. People like me are in the committers group. At the moment, these are about 18 people. They have generally the responsibility to keep the project going and to do reviews and to contributions, but not very much. They're very sufficient to keep the status if you do one contribution per half a year or so. But of course, the idea is that people do more as far as they see the need for. Besides, or part of these committers are the OpenSSL Technical Committee. They are those who take technical decisions on the project. At the moment, these are 10. And another group is the OpenSSL Management Committee, which can overlap or not. As you can see in this picture, there's one guy who is not a committer, who is part of the OMC, but everyone else is also a committer. Oops. And after that, you will stay a committer until you are not active anymore, basically, or anything went wrong and you're kicked out. The interaction between the OTC, the technical committee, and the management committee is pretty intense, I think. I don't get much of this in my daily life as a committer. They meet online every week. And actually, this is also the team that does actually the bulk of the actual tech in the development themselves. So about 2/3 of the non-trivial commits to OpenSSL is done by the OTC. And about 1/4 is from committers like me, who are in part paid by their respective companies. And the rest is by individual contributions by other people. There are very rare face-to-face meetings of the OpenSSL team. It was very nice that one of these were last year, where I was able to participate, at least for one day. You see a picture here of the OpenSSL OTC and OMC members mostly. And on the right side, because this was hosted by Red Hat, we had some Red Hat people over there. And spot the bug. This hat is not red. But thanks, Daniel. Here's the bug fix. We also have a Signal group where we can do some more informal exchange in the OpenSSL team. As mentioned, it's always a struggle to get pull requests into OpenSSL for good reasons, of course, and for quality. They decided about 2 years back, okay, someone who brings in his own code, even if he is a committer, should have some other person to review that, so 2 other persons now. And this again slowed down our contributions quite a bit. Normally it's rather easy for that one person reviews this round, but getting a second review by an OpenSSL committer can take not only days, weeks, it can take months. For this reason, it's sometimes also really good that we know each other a little bit and then can ask, would you be so kind and do some review for me? Still in OpenSSL, there's always a backlog of around 300 to 400 pull requests that are not yet done for various reasons. for either waiting for reviews or for waiting to reactions to the reviews by the contributors. Yeah, and so what I do, I currently do both of the roles. First, I was mainly contributing. Meanwhile, I also started reviewing a little more. Also because we found it's more efficient. If not I do our currently open CMP additions and fixes, but let a colleague do it for me. And then I can act genuinely as a reviewer together with some other OpenSSL colleague. And because, of course, I'm motivated in helping getting our things in, at least this speeds up the process. And as you can imagine, there's quite a number of things to take care about when reviewing. Is this contribution relevant? Maybe is the technical solution that is being proposed, is it good, or maybe some other better alternatives? Is it correct? Does this bring in any potential crashes or memory leaks? Is the coding style right? Does it include sufficient documentation? Are there enough tests included? And does all the CI runs pass? And also this reviewing is not just a technical activity, it's also about a social process between the reviewers and other people, to collaborate. And so there is also helpful to know each other, trust each other, and help each other. And when there's delays in reviewing, this can be cause extra overhead later, because in the meantime you will simply forget about the details what has been contributed. And there may be concurrent changes by others who then cause merge conflicts. So it's really good to, whenever there's a contribution coming in, to get it reviewed by the two people quite immediately. And it's much more efficient than lay things around. In total, I've contributed to OpenSSL at the moment 500 pull requests. There's still a couple of them open, about 30, where I don't have the time, or the others didn't have the time to really pursue on them. But hopefully, gradually, they will come in. And when I find the time, I also review other people's stuff. For example, recently there is a bigger extension about CSP multi-stapling by a former colleague of our team, who meanwhile is at BMW, and therefore, although it's a lot of work, I'm more motivated to do some reviewing there as well. So I come to my conclusion. OpenSSL still, for various reasons, is the most important security library, also for Siemens. And we have started doing major contributions to this. And to this end, it was really helpful to become an OpenSSL committer. Also because in this role, I learned quite a lot about coding, about tools, about the software processes behind. So this really speeded up our contributions quite a bit. And with the more insight that I have, I can also leverage this for fixing other things in OpenSSL. That would also be helpful for our company and others. And as we've seen, it's not only about technical stuff, it's also about social interaction with the people in the team. And it's all quite a lot of work. And it's not always paid, some of the things I do in my spare time, but still it's quite some fun, so I find it rewarding to be part of this important open source project. That's what I've prepared for you. Thank you for your interest.